So I've got two microphones on. I hope all of you can hear me clearly. Thanks for having me. I have found myself, moving towards public health, epidemiology, and so this is a great place to be. And I think I have a lot to learn from you all. I know I do. So, again, thanks for having me. I look forward to talking more. Let's see. I guess I'm going to have to use the laptop to go through my slides. So, start with acknowledgments. These are sort of my primary co-authors on this work, and I'll post them up at the end again along with some contact information if you're interested in getting in touch with us. So I'm starting with this just to give the bird's eye view of, this is literally the context of the research that I'm going to be talking about, but also really sort of the starting point for at least my thinking as far as this work goes. Whether it's smoking cessation, tobacco use, or anything else, they happen in real world contexts. And this is a very complex thing when you realize, here I'm the clinical health psychologist. I know to all of you and epi folks, this is sort of taken for granted, but I had this epiphany, wait a minute. We focus a lot on individuals. We have them in things like clinical trials. We take them in the lab and we send them out into the real world, and then we proceed to totally ignore all of this complexity. So this is a really complex covariate to try to understand in your models. And what my work does is founded on the idea that we can use the real-time link in time and place that we can get from mobile devices to put people in the when and the where and link them up using geographic information systems and other methods to try to ask interesting cross-level questions about individuals and their context. We're not the first people to do this by any means. Folks in the physical activity world have been doing this for a while and really, I think, leading. This is another interesting example. This is a letter published in Nature by Stephen Eubank. You probably can't read that in his group. These are folks who do dynamic, really math-based modeling, but they've really done a lot of important work looking at the way germs and infectious disease spread through urban environments by understanding and studying the way individual mobility puts people in contact with each other and the way that's really bounded by the different urban environments they find themselves in. Now, of course, there are many other factors other than germs, and from the very beginning, the way cities grew was very much related to economics. And city planners have been aware of that forever. This is a really cool map I found. This is from San Francisco, 1923, October 24th. So this is exactly 90 years ago. And what you've got is, I don't know how they did this, but they counted pedestrian traffic. And they essentially drew a heat map that's relative to the number of pedestrians that were measured. This is Market Street in San Francisco. So this is an early attempt to try to understand pedestrian flow, presumably to understand economic development and things like that. There's another seminal work by Jane Jacobs, many of you I'm sure are familiar with, the Death and Life of Great American Cities, which is a really interesting book. There's a chapter in there called The Need for Short Blocks, and it's all about the fact that it's individual mobility that reciprocally determines the small business and economic environments of a city, and how even just cutting a single lane can make a huge difference as far as what products are available and what the product landscape looks like in a city. So this is where we sort of move towards our work. There's been a lot of focus on toxins like germs, a lot less focus on toxins like tobacco products that are distributed throughout landscapes. And I'm not going to go into it in great detail here. Maybe it's something for discussion afterwards. But it's interesting to think about the parallels between a germ and a tobacco product in the way humans interact with them and so forth. But I'll leave that for now, but I just want to introduce, this is some of the data that we've collected in DC and the foundation for some of the work I'm going to talk about today. So on the left here, you've got Washington. Red dots are tobacco outlets. And this is the mobility pattern over 1 month of one participant in a cessation trial that we ran. On the right, you have a 3-day subsample of that person's mobility, and you have it overlaid with outlets buffered by 30 meters. So that's why those are a little bit more than dots. And I start with this because there's some important things that jump out that I think are sort of lay the foundation for this. First of all is, I guess, what I call sort of a regular randomness. So regular in the sense that the degree of redundancy here is remarkable. And it sort of makes you think, too, about, I said to Ryan when we were meeting, we like to think we're not like migrating geese, but in some ways we kind of are. We're very much creatures of habit. This may be more of an extreme example of that. But some things pop out on the right as well. So it's very regular, but when you think about this person's experience of the point of sale environment, it's random. We can't predict where this person is going to go. And there's a couple of implications of that. First of all, it's not equivalent. This person's experience of the point of sale environment is not the same as what we might measure like we traditionally do about the aggregated point of sale environment. So it's not enough to just say that the average price of a pack of cigarettes in this area is $5. I'm going to give some specific data on this later. We need to understand the pack of a price of cigarettes at the outlets that this person is choosing to patronize. So the other implication, just from a methodologic point of view, is that because we don't know where people are going to go, we can't use the standard methods which involve sampling across areas or sampling around features like schools. We need to have information about what's going on at every one of these outlets if we actually want to start to study details about this person's experience. So one of the first things I'm going to do, then that sort of sets up the talk in the sense that what I'm going to start with is where we went with that and the methods that we've developed to do comprehensive surveillance, not only in DC, elsewhere in the country. After I do that, I'm going to talk about how we link that information to each individual and try to understand behavioral outcomes linked to that data that we collect. And then, if I have time, and I put these slides together in a way I haven't presented them before, so I'm kind of winging it on time. Depending on where I am after that, I'm going to talk about some of the systems we've developed for collaboration and dissemination. These systems are very much things that we can work with other groups on, and we are. So I can talk more about that if we have time. So we needed information on every outlet in the city, and what we started with was a geographic information system. We started to build our capacity, and it's been a couple of years ago now. We had a team of field workers, and we would create cluster randomized routes. We would send them out into the city, and they would collect a range of data, including photographs, but they'd walk into each outlet with earphones plugged into a phone. They'd look like they're a teenager on their music, but the earphones would be an interactive voice response saying, what's the price of a pack of Newports? And they could answer by looking like they're texting by hitting, say, 7*75. So they could go in and survey what was there, as well as we would have the partner they were with would take photos, interior and exterior. This shows some of that. This is sort of a mobile version of this where it knows where you are. It links you up to your real-time environment, and you can find the outlet that you're in front of so that you can tag it. And then that's just some of the technologies we use nested in the cloud to do this. Really what we're excited about now is the use of photographs. Photographs, it's another thing I could talk about, and I'll restrain myself for now, but one of the things I guess I would point out about photographs that's really interesting for surveillance is that you don't have to write the survey ahead of time, right? If you can get them, and if you can take quality photos, and if you have systems to process them, you can go back and mine them for things that you didn't know were there. And so I can give some examples of that too. Just to make sure I'm being clear, I'll give you a quick one. We found out while we were still in the field that Marlboro was launching a new product, Marlboro Black, in December of 2011. We had no idea. The survey was set, locked down. We were able to go back to the photos and see where the product was and at what price point it was being introduced because we had the photos. So what we're doing here, we have a custom Street View camera that we drive around DC with. And we also, these are the HD glasses. This is a pre-doc that I'm working with. He's collected close to 100,000 photos now in almost every outlet in West Virginia. So I told him, well, he can just retire and publish on that for the rest of his life. So the problem is we have thousands and thousands of photos, and how are you going to extract all the information? This is an example from West Virginia where it's sort of the Wild West there as far as point-of-sale tobacco goes. And this is him just turning his head as he looks at a tobacco wall. Notice some of the problems. You've got a lottery stand here blocking some of the images. So what we do is we stitch it together so that we can have a single sort of target, and we can deal with this lighting. I didn't in this example, but now we have a single target, so we have a comprehensive idea of everything that's in the store. The problem is it's still way too much information, and so what we do is now that we put it together, we chop it apart, we zoom in, and we use crowdsourcing methods to extract information about every product in the store. Distributed human computation, Amazon Mechanical Turk is the platform that we use. If you're familiar with crowdsourcing, it's another whole thing that I don't have time to really go into. But suffice it to say, I mentioned chopping them apart. You can see down here what a typical task might look like. Each little bit can be broken down into a very short survey. And a key thing with crowdsourcing is actually that you're really lowering the burden on the coder so that you can maximize reliability. So these are easy questions. Brand, whether they can see the price and what the price is. We can send this to as many raters as we want and keep an eye on our reliability. So, forget about 70% agreement between interns. We can do much better than that with this sort of platform. It's also cost effective. This is an example of where we processed with 15 independent ratings, over 1,500 photos in under 4 hours. I think that one costs about $2,500. So it's feasible from a cost and time perspective as well. So just some quick examples of what we've learned. Before I get back to our individuals walking around through this space, I wanted to talk about a little bit, just again quickly, a couple of slides on some of what we're seeing at the community level as a function of doing this work. One interesting thing that's going on with the FDA and also the National SINAR program, if you guys are aware of this, these are basically sting operations where municipalities send an underage person into the store to try to make a purchase. They do use a sampling approach, and so if you see here, we've got red dots that are outlets that were inspected by the city and green that weren't. A nice thing about the fact that we had the census information was we had information about every outlet in the city, and so when we decided we wanted to try to understand what sort of spatial community factors might influence the likelihood of a violation given an inspection, we were able to control and make sure there wasn't something different about the outlets that were inspected, systematically than those that were. And fortunately, we found that it was fine. So for instance, the distance between outlets that were inspected to DC area high schools was not different than the distance from outlets that were not inspected. And so there wasn't, so any association we might be able to see between the probability of a violation in high schools was not due to some sort of biased selection of those outlets. I can talk more about that. But anyway, so what you got as example here is a calculation from, this is Turkey Thicket Playground and LookSee High School. You've got a number of outlets, and we calculate the street line distance from each outlet to each feature. And we build logit models that then are multivariate, so we can look at the relative influence of being this close to a playground versus this close to a school versus this close to a public housing unit. And we can also have in those models things like the point of sale marketing practices and the socioeconomic block group information for each outlet. And we can look at the relative leverage of all those different sorts of factors. And we see some really interesting interactions, and I'm just going to show you one here. So what you've got is the predicted probability of a sale given in an inspection. And here you've got proximity to a DC park. And in DC, we have to get rid of parks that are like monuments or triangles or this stuff all over DC. These are parks that have recreational facilities. And the proximity is getting closer as you move this way on the X. And what we're crossing it with here is the presence of exterior ads. This is an important question right now. FDA is weighing whether they have the legal data, to back up a fight with the industry in court about whether they can ban ads in the exterior. So far, they haven't been able to do this. The effect that we see here is that as you move closer to a park, the probability of a sale is increasing among outlets that do have exterior ads. And we see the opposite trend for outlets that don't have ads. Now, I don't know why this is happening. We're actually proposing an agent-based dynamic modeling approach that'll help us ask why questions. Because this is observational data. It's hard to make firm conclusions about what might be going on. Our hypothesis is this might have to do with increasing the flow of basically increasing the number of opportunities. We're very much thinking of this from sort of an economics point of view, the idea that outlets want to increase revenue, and when they have more opportunities to sell tobacco, they'll take them. There's alternative hypotheses, such as clerk effects. Maybe some of the sales are based on different types of clerks in different types of stores. It's hard to know. This is where dynamic modeling can be helpful. So related to the economic sort of side of things, this is a paper we recently published in American Journal of Public Health showing the differential pricing availability of little cigars and cigarillos across DC. On the left, you've got proportion African American per 2010 census block group, and on the right, you've got predicted little cigar cigarillo price, and we see significant covariation between these factors. We also see this with menthol. We see the price of a pack of menthol cigarettes drop by about $1 with a very similar sort of gradation as we see here. And we know that kids are price sensitive. And so this is another example of a factor that may be explaining some of these sales data, but we can't put them together yet. So we're trying to get there. But this was sort of inadvertent, but the methods that I've been describing so far have, they've opened up some avenues for doing some of these analyses. So back to, our individuals moving through the city. We've got all this information at the community level now. How do we link it up to these individuals and ask specific questions about their behavioral outcomes? I mentioned that the aggregate information we have about where these people live is not equivalent to the information about their own point of sale ecology. You can see that over 3 days we had a mean of 2.3 outlet touches across a total of 6 outlets, with a mean Newport pack price and little cigar and cigarillo pack price for this individual, just to sort of drive home this idea that each one of these folks not only is experiencing coming into contact with outlets and more or less frequently, but that the products on the shelves and the marketing practices at each one of those outlets varies dramatically. And almost always, you see selection such that these sort of numbers like this are lower than the aggregate number. And I'm going to come back to it, but as I'm sure most or all of you are very aware, there's some real challenges to inference when we start talking about associations like this with observational data. So I think it's a challenging topic, but it's a good one to talk about, and not necessarily a fatal flaw. So how do we know where these people are? I just want to touch on the geolocation methods that we're using quickly. Again, I don't know, maybe this is a question that will come up. I've had some conversations this morning with folks who are thinking about using different technologies. And there's a lot to explore as far as what you might use for an individual study. But one really important advance in recent years is the ability on just consumer available phones to understand precisely where people are at any given time. And that includes, it's easy when people are in an open field under a satellite to get a GPS read. But when they're in between buildings in New York or inside, things get a lot sketchier. Fortunately, a lot of phones now use Wi-Fi signal and what's called trilateration, which is kind of conceptually similar and mathematically similar to triangulation, that use the signal strength of towers or Wi-Fi hotspots in the area to try to, when you're on your iPhone or whatever phone you have, you often see a little circle that's going like this. That's the algorithm winnowing its way in on your location based on the location of these points. Now, one thing that's really interesting, though, that I just wanted to show you all is this is for the DuPont Circle area. These are CDMA and GSM, which just means cell phone towers across the DC area. Then I want to show you the Wi-Fi hotspots. And these are red hotspots are those that are password protected, and green, which are public. And an important thing to know, if you're not familiar with this, is that as Google, for instance, drives around with their Street View cameras, they're collecting all this. You don't have to log into a Wi-Fi hotspot to log its name and its location. And neither does your mobile device have to log in. You can still, with a database, which Google maintains, and the mathematical algorithms that you need to make sense of both the signal strength and location of the points, you can get geolocation around these devices within like 3 to 7 meters. We're using this as well, not just with the cell phones. We have a beacon that there aren't many that can do this right now, but we're working with Google, and we have a beacon that, as you carry it, will collect up to 30 Wi-Fi hotspots and signal strength, and thus can be used to get geolocation with a very high accuracy. And it's a nice thing to have. Like, if you're, one of the projects we're working on is a collaboration with a group in Tulane who wants to look at kids walk to school. They have information on food, alcohol, and tobacco. It's really helpful if you can say to parents, you know, we're not going to put a tracking app on your kid's phone or something like that. All they have to do is carry this brick. It doesn't store data on the device. If it's lost, it's totally de-identified. So, just methods. This is for DC. You can't see the boundaries in here, but you can't see it in this slide. But it's just interesting to look at. These are the mobility routes of individuals. This is downtown DC. This is the corridor heading into like Fairfax, Virginia. Kind of looks like a cardiovascular, you know, or neural network. So you could get philosophical, I think, about that. You know. Anyway, okay. So how did we link all of this up to a set of individuals, and what sorts of questions did we ask, and what did we learn about how folks are impacted by what we're measuring? Well, we ran a clinical trial, and this was funded through a grant that I got through the NIH. This funded a project where every smoker in DC who called the DC Tobacco Quit line was given the option to enroll. And if they did so, we provided them with a mobile-based smoking cessation support system. And the idea was that essentially it was a diary. The way we presented it was, look, we're not going to send advice to you. What we want you to do is use what's called personal informatics. We didn't use that term. We just said we want you to keep a diary. This goes back to the bread and butter of cognitive behavioral therapy, self-monitoring, functional analysis. If you understand a behavior better, you're better empowered to change it. And that's what we said to these folks. Keep track of it, learn from your own tendencies and what works for you and doesn't. And we also explained that we suspect that the point of sale environment and where you live is going to be an important thing. It's one thing we're planning on studying, and if you'd be willing, we'd like to learn more about that. And we want to track your location on the phone so we can do so. And we also talked to people, we also offered folks the ability to learn more about their own exposure. And I often get questions about, you know, privacy and consent and things like this. I tell you what, people are very interested in this stuff. We had no problem at all. People said, of course you would study that, and yeah, that sounds interesting. So we had, it was in the vicinity of 90, I've got the figure later, but most people were interested and gave us consent to track their geolocation. This is just some screenshots of the application screens, and you can sort of see the sort of feedback a person might get. Well, you probably can't see it, but this is telling the person their average craving level, their top trigger, the time of day. There's a social networking feature to it. But you know, this is that intervention part is another talk. This is just some general information on the sample. 89% of the folks who were offered the ability to do the geo-tracking element accepted it. We have an average of 27 days of geolocation and EMA data over pretty much the first month of their attempt. About a quarter of the days ended up being a day where they had a slip or a lapse where they were still trying to quit, but they did smoke a cigarette. When folks relapsed, they were censored. The data that I'm going to be talking about doesn't include folks who gave up. This is the geo-coordinate set. So this is the proportion of times we were able to get a fix on the person's location. In the lab I trained in, Saul Schiffman's EMA lab, we call this the sock drawer problem, which with EMA pretty much refers to the problem of burden and the point that a person puts it in the sock drawer and walks away, and the need to minimize burden. I'm not going to go through all of this. This is sort of stuff that if people are interested in the logistics of running studies like this, I'm happy to talk about. But basically, I've got a bar chart saying that given the level of how annoying this sort of research can be, that these were pretty good numbers. I mean, so for instance, this helped them track and learn about their quit attempt in 8.8 out of 10. Annoying was only a 4.4, so we wanted to keep an eye on how painful this was to participate. We also, I guess I'd note, we provided the devices to folks in this study. It was a very strong incentive because the way we incentivized them was we gave them unlimited use of the device. This was a low-income community in Washington. We didn't want to have to exclude anyone over the ability to run our cessation app. We also wanted a nice way to incentivize. It was a very, very strong incentive, though. And so we had to actually really be pretty tough with our eligibility process. Folks had to come in person to do both breath and saliva-based assessments to verify that they were a smoker in the first place. Before they quit, they then had to come back in and use a carbon monoxide measure to prove that they quit. And then they had to come in after 30 days to do another bioverification. So this was sort of my first big trial, and I said, if nothing else, I want the data to be valid, So this would have caused, though, this is a highly motivated group, as is the case for most of the studies in the literature, but it's worth noting. These are some compliance data. They were pretty good, so the proportion of completed prompts was about 80%. As far as EMA studies go, that's about as good as you generally can expect. Sometimes you see better. Remember, people they go to church, they go to school, they go to work, they can't always respond. We saw a good amount of self-initiated entries, so people were complying with this idea that we wanted them to tell us about their, for instance, their lapses. And so we were seeing a good level of engagement. So most of the metrics that we keep an eye on looked pretty good. So let me show you some of the data. So this is just a histogram. We're looking at the distribution of average retail exposures per day. And this is the number of participants in each bar who had an average of that number. And then on the right, we have variance in daily exposures. So we have the between and the within variance. We have the overall standard deviation, and then we have the variance between subjects for each point in the process. I guess this is just, I partly put this up, it's just descriptive. Part of it, though, was pretty interesting because we had no idea what we might see as far as this goes. There's some interesting future questions about what this distribution might look like in different urban environments, and there's some interesting sort of modeling questions. Actually, let me go to the next slide. This describes a main effect, and this is also where I want to sort of broach the problem of inference from observational data. So what you've got here are on the Y, the predicted probabilities, the odds ratios of a lapse on a given day. And then you've got the number of post-contact, point-of-sale tobacco contacts in that day. And we see a pretty strong main effect. Now, I've got a little more to say about this, a couple of different angles that we took to try to understand what might be going on here. But again, I want to broach this issue of observational inference because it's a problem, and I've talked to some other folks who do work like this who have, struggled with it. One possibility, so you basically got three variables, right? We've got, on each day, we've got, well, I haven't, actually, I said three variables because I'm more familiar with this data. We do have three. We end up crossing things with craving, but I just got ahead of myself, and I hope I'm not confusing you too bad. But let me not go there yet and just back up. We've got two variables here. We've got whether or not they come into contact with an outlet and whether they use tobacco on that day. Now, it's very easy to just flip that relationship, right? And it's actually a good question to ask. Well, aren't we just seeing that when these folks were going to have a lapse, they went to the store, they bought a product, they used the product, and that's why they came into contact with the point of sale environment? It's an important question. And similarly, I'm going to describe an effect here where we saw an interaction with their level of craving on that day. Similarly, you might expect going out and using the product not to be the dependent variable, but to actually be driving contact with point of sale and craving. You have a high craving, you use a cigarette, and your craving goes down. So it's an important question, actually wrangled with for some time. And I can't definitively, we can't randomly assign, and this is probably me also showing my naivete to epi methods and things like this. I'm used to tightly controlled experimental stuff, and when I realized, oh no, this is a real challenge, I've been struggling with it somewhat. I sort of have come to believe that even though we can't draw firm causal conclusions, that we've got a case to be made that the direction is sort of the intuitive one or the a priori one that we started out trying to look at, which is this idea that as people are moving through landscapes of outlets and products, that is having an influence on their decision making or their ability to stay quit. And the reason that I say that is, look at the way this effect is growing not necessarily linearly, but it's growing additively as additional contacts happen. We were able to go back and look at the data on the lapse events, and what we know for sure is that when lapses happen, they tend to be singular events. So this is to say, person tends to have not only one product, but one unit, one cigarette, and so this additively accumulating effect of post-contact, this doesn't necessarily just fit, even just conceptually, with the idea that that the use is actually driving this effect, because people don't need to go to the store this many times just to have a singular lapse. I'm trying to remember what the percentage is. It's something like almost 90% of lapses that happen involved a single-use event. And so, again, we wouldn't necessarily see this growing effect of exposures if what was happening was that single use was actually driving contact with point of sale and craving. So I hope that was reasonably clear. It's an armchair sort of epi person trying to make sense of this observational data, and I'm curious what you all think. So let me just go on with the narrative. The interaction we saw with craving violated our a priori assumption. So going into this, we basically just said, we think that when folks, it's almost like a Q reactivity thing, when folks come into contact with the point of sale, they're going to be cued, their craving is going to be higher, and they're going to be more likely to have a lapse. Now, that may have happened, but with the daily level of, with the way we looked at this data, we're not able to definitively conclude that. But I can tell you about the direction, and it was opposite of what we expected. So let me be specific. If you look here, we've got the probability of a lapse on a given day. We've got point of sale tobacco contacts. And we've got this crossed with the average rating. So they're reporting their craving over the course of the day, and we take the rating for that day. And so you've got just about half the days with a very low craving. These are days when folks are basically saying, I'm quit and I'm fine. You've got days where they've got low to moderate, 1 to 5 on a 0 to 11 scale. And then you've got days, and I need to get my line there, but anyway, you've got days where they're struggling, where their craving ratings are very high, and this is on average. So these are days where they're having trouble on a significant number of occasions. And what we see is that really where the point-of-sale tobacco contact effect comes in is on those days when they were otherwise doing well. So it's what seems to be happening is on the days when folks are otherwise may not have used, when they're actually feeling pretty solid about their cessation attempt, it's on those days that variation within that group in their contact with the point-of-sale retail environment seemed to influence the likelihood that they were going to actually ultimately go ahead and lapse. I'd expect that within that group, my assumption is there was some sort of queuing thing going on, but again, I don't have that analysis in this actual presentation. So it's interesting to think about. In post hoc, it's actually consistent, and we try to lay this out in the paper that we published. It's consistent with what's been seen in laboratory experiments, for example, where if you bring people in in a very deprived state where their craving is very high, they're not as differentially reactive to different kinds of cues in a laboratory. So it kind of fits with some data that we've seen in the lab. And it makes sense post hoc. It'll be interesting to go at an even more micro level of analysis to try to actually observe what we're seeing. Another thought that I'd like to do is bring people into the lab. So we can measure people's sort of individual point-of-sale ecology. We can get an idea of their level of exposure outside. We can then bring them in the lab in different deprived or non-deprived states, and we can look to see in a more controlled environment whether or not we can get more of a directional effect, basically confirm what we're seeing, that this subjective craving or deprivation effect is influencing the way they process point-of-sale images or whatever stimuli we want to show them, and say attitudes, behavior, intentions, maybe follow behavior afterwards. This is sort of it's something we haven't done yet, but there's some ways, suffice it to say, that we could try to understand the phenomena that we're observing here. This is a cartoon that I think is funny and kind of touches on some of what we're talking about. I think I just basically did this slide. And we can come back to it. So just a quick recap. I have more material, but this is sort of like an intermediate recap. The point-of-sale landscape is not a static community-level factor. Each person has their own point-of-sale landscape. And mobility drives exposure, but we suspect also varies with individual receptivity, reactivity. An interesting thing about this line of work is different from germs, where or particulate matter. You just inhale those. When you start talking about exposure to retail or other features like that, it's all of a sudden subject to all the suite of psychological subjective filters that actually there's a lot of research on. So it's more interesting for that reason. And I just talk about some work we're doing. We have an R21 now to look at e-cigarettes and the interesting way the e-cigarette landscape is evolving at the point of sale, and the way regular smokers are starting to experiment with e-cigs. And there's a lot of debate right now about whether they're just using them to bridge, meaning when they can't smoke, using them when they can't smoke, or whether they're actually using them for cessation, et cetera. Okay, so this is my attempt at a humor slide. I don't know if you guys remember Deep Thoughts from Saturday Night Live. If a smoking cue falls in the woods, does anyone react to it? And I tried to get a picture of a cue you might see in the middle of nowhere, or probably a lot of people don't see. I was on a panel where my mentor, Saul Schiffman, said, he was starting the discussion, and he said, if a smoking cue falls in the woods, the point he was making, and actually Ryan asked this earlier, it's a good question, is, with the methods that I'm talking about here, we're trying to minimize burdens. So we're saying all we want to do is, on the one hand, look at individuals' mobility, and then totally separate, we want to collect our own data so that without bothering people, we can put the two together and we can link them up. The problem with that is we don't actually know. I think you said the person could be on the bus reading a book. And so it's true, and there are some ways around this. I think Bill Shado was here recently, and they're sort of taking a different approach where they're not, I don't want to unjustly criticize their work, but they're focused really on the subjective side. What do people think they see, when they go into these stores? And we're over here saying we're going to try as best we can to measure what's actually there, which are different and equally interesting and complementary sort of questions. We haven't done that yet, but one way before we bring in subjectivity and try to start actually bothering people and asking them what they see. One thing we can do is we can go back to the information we have about what's in each store. So these aren't when people come into contact with each store, they aren't just blank slates. The stores have some stores have exterior advertising, some don't. Some have huge power walls. Some just have a little thing of cigarettes, that you can barely see off the back counter. Some are restaurants, et cetera. So if we can demonstrate that there are store-specific marketing effects that explain some of the variation in what we're seeing with the individual behavior, we can get a little bit closer to a claim that it's something about actually seeing the marketing. I mean, are they consciously aware of it or not? Or, there's a lot of questions I can't answer. But it's one little entree we took to try to get at this question. My time says 48 minutes, so I guess I think I can do this part quickly, and then, am I okay? Okay, I'll just go fast. I can go fast. See, this is what you get when you, okay. When you throw your slides together, this is what happens. So this is a slide. Let me this is showing the distribution of different store types. And you've got real-time exposure, meaning you can see we've got a confidence interval here. So this is distributed across our individuals moving through DC, the proportion of times they came into contact with a store of that type. And then you've got bars representing the actual relative proportion of stores of that type in DC. And there's an interesting, it makes sense that you would see them correspond to one another. It's kind of interesting to look at. And then, again, so we have the probability of a lapse given contacts with specific store types. And if we look at those that we seem to have an effect, we see a strong effect, strongest of gas stations and less so of convenience stores and liquor stores. So what's going on there? We suspect that it had something to do with exterior marketing practices. We also wanted to look at that because it's something FDA is interested in. So we did an analysis where we looked at that, whether or not there were ads on the front of the store for cigarettes. And these are odds ratios, and down here we've got stores that had interior presence of tobacco on the interior of the store only, and then you've got interior plus exterior. There weren't any stores that only had exterior, not one. And essentially we see effects of whether or not there's advertising on not only, this is signs on the interior. So some stores, as you're probably aware, some stores like takeout stores will have a pile of cigarette packs but no signs. These are stores with signage on the interior. And so we see a significant effect of contacts with stores with signage on the interior. And then above that, we see an effect of stores with signage on the exterior. So, I don't know. I think it's interesting that it sort of backs up this idea that our results aren't just an artifact of some other third variable that we're not measuring. But as you know, this is tough stuff. So basically you say that here. We have some evidence that outlet-specific features, namely point-of-sale practices that we measured, matter. We're really interested, by the way, in extensions to alcohol and food products. Again, a place where photos become very useful. And see remarkable variation in this across Washington. I'm sure it's the case in Baltimore as well. In the lower income neighborhoods, even more than tobacco, just plastering of alcohol advertisements. I'll stop there. I have a few other slides here that present our new GIS portal, and I can talk to you about the sort of things you can do with it. And this also supports a number of collaborations we have now and hope to form moving forward. We're able to provide devices and allow other groups to collect geolocation data. we're able to link that data up. For instance, this is the comprehensive landscape of all the FDA point of sale inspections that have been conducted so far. We see some really interesting and exciting opportunities for not only dissemination, but also for collaboration. And so, I mean, hopefully this would be an opportunity to talk to some of you about, working together. So I'll stop there, and I'll go to my thank you slide, or my acknowledgement slide. Thank you all for your attention. I've got my email on there if you want to talk more. So thanks a lot. Okay. Okay, let's go here and then there.
Great presentation. I'm just curious, since you mentioned that you've had such individual variation with people who come in contact with the point of sales tobacco, I saw that you took summary information from everyone in your graph. Especially since you have intensive data, have you looked over days, the 30 days, and looked at individuals, what different patterns you notice, so you can get more behaviors?
Yes. Yeah, I have one of the papers I'm trying to write and get out, but you know how that is looking at that. So an approach I took to that was I used M+ and tried to look, used a mixture analysis to look for what I'm thinking of as mobility clusters. So thinking about days as the unit of analysis and having days clustered within individuals to control for that variation, but trying to find, assuming that some people have days of one type where they have a lot of content, some people, and each of us have days with different levels of variation, like you just said. Finding clusters of different types of days, and then nesting that within weekends, and then looking for and what we see, for instance, once we form those clusters, we can look at their association with things like intermittent smoking patterns. And so, for instance, one thing we're seeing is that being an intermittent smoker, you're more likely to have a certain type of profile on Saturdays, where exposure profile, whereas more regular smokers have more of a constant type of profile. Sure, that's a good point. I didn't. Yeah. Yeah, thanks.
Yeah, thanks a lot for that presentation. When you looked at the exterior signage, did you do any content analysis of the signage, and in particular, was it all price advertising, or did you separate out price and look at price and non-price advertising?
Not in this analysis, but yes, we are doing. I talked about the crowdsourcing, and there's too much to get overly detailed, but some of what we did do was try to break things out by brand and type of product and presence of price. We tried to look at tax too, but it was too noisy. There's actually not as much variation as I would have expected. In DC, I can tell you that almost all, so of the 750 outlets that actively sell tobacco, there's about half of them that have exterior ads on the outside of the store. And again, I'm throwing out percentages here, but it's like over 80% of them that have Newport, I don't know what the dimensions are, but you're all familiar with these 2x3 Newport ad. It's Lorillard, basically. I don't know what, and it does have to do with the way tobacco contracts work. You know, each store decides if they're going to contract with Lorillard or with R.J. Reynolds or with Altria, and that has implications for things like signage. And so the stores in the parts of the city that do tend to have more advertising tend to contract more with Lorillard. And so actually there isn't a ton of variation there, at least on the exterior of the store. On the interior there's a lot, but the interior is like a Pandora's box I haven't opened yet because it's so complex that how are we ever going to, understand what's happening there?
I've really seen those photo glasses and your new collection in store. I imagine that you use them
Yeah. No, it's funny. I never thought I was going to go the sort of the spyware. I mean, you can go to these spy sites, and a lot of the stuff on there is really crappy and won't suffice. We played with one called a LookSee, which is this thing that looks like a hands-free, phone, the Bluetooth phone. And it works well, but it doesn't have the high enough resolution. So I was loving this thing. I was wearing it around, but we went into a supermarket where they had a counter and then like probably from here to there, just their cigarette display, and couldn't read the prices, couldn't see it. And so I was like, shoot, it ends up that there's a market for these things growing, and the glasses that we ended up finding that do work are these that are they're made for the extreme sports market. So kids want to go off the snowboard jump and record it. So this is just like with the geo-trackers. The only reason we can do this stuff half the time is because there's a market for it for some other reason. There's a geo-tracking market because small businesses need to be able to track their boxes and stuff. So anyway, these glasses are actually, they have software that comes with them that enables us to put them on a constant photo clipping like every second or 2 seconds. That's critical because two-party consent laws totally make it unfeasible to use video or audio. But photos are more protected under the law, and unless you're asked to stop taking photos, you're probably okay. Before we got to these glasses, the reason why I ended up going there was just that the pressure on our field workers to take these photos was pretty bad. I mean, we had to have some solid, not bashful field workers to do this, because you can imagine a lot of times you walk into a little place, it's just you and probably the owner behind the counter. And you're supposed to take photos. It can be very tough sometimes. So just the stress on our field workers was one thing. Also the data, and ultimately the data is more, the data that we're getting from these glasses is comprehensive. So the problem with an individual photo is you don't know what's not in the frame. So you can't rule things out. So even if they miss just one section of the power wall, you don't know what's there. With the glasses, also you have to spend like 15 minutes in the store. With the glasses, all of a sudden, in 2 minutes, you can get comprehensive, high-definition coverage of everything in the store. So think about, and it's almost too much. I mean, it's a big data problem in a way, but. So, it was too enticing, I guess, in a way of saying it. It's also just so much easier for our staff because you can just throw these glasses on, and we've had one time, you saw the picture of the guy who's doing a lot of it earlier. One time a woman, the light hit it just the right way, and she said, "Oh, cool, is that a camera?" And he said, yeah, I use it for mountain biking. So, I mean, there's questions about deception and whether or not you say anything. I'm still struggling with them myself. I mean, being at Legacy is nice because we have lawyers there who are used to fighting with the industry. And so they've helped me with some of that two-party consent stuff. I should probably be a little careful with what I say now. I'm not enthusiastic about letting this out. I mean, I want to tell crowds like you, and eventually I know that we're going to be on the cover of Convenience Store News. But on the other hand, this is happening culturally, right? I mean, you've got Google Glass coming out, and there's Microsoft has a new set of glasses. So there's a lot to think about, and any feedback or even like negative or positive reactions that people have, I really want to have those conversations. So if anybody's like feeling very uncomfortable about this for any reason, I actually would love to talk to you and enlighten me, help me like as I try to struggle with this, know how to deal with it.
Touched on the crowdsourcing for coding photos. Can you just say a little bit more about how that's working in practice and how you're getting people to do that?
Yeah, and we're writing a methods paper now that we're going to be able to distribute that'll help. I mentioned, it's a pretty exciting thing too, because I mentioned some of the way it can improve reliability. This idea of 2 independent raters agreeing 70% of the time. That's exciting, and we're developing some statistical methods to try to understand that. I won't go into what those are because it would be I can talk more about that, but we're trying to identify, for instance, for anybody who might do a task and want to know what's in a photo. You could go to a crowdsourcing site. You can't really go there and post it. You have to have an IT developer who can help you do this. But for the sake of this, you get a photo onto a site, and you're going to then ask a group of random people in the cloud, to tell you what's in it and answer a couple of basic questions. How many people should you use? If you ask 3 people, you are often going to get perfect agreement. But of course, we know from Statistics 101 that those are small samples. And the variation between samples of 3, if you were to draw, and this is some of what we're doing, we're using resampling, where we've drawn, like, for instance, 500 samples of 3 to try to look at the variability across samples of 3 versus samples of 4 versus samples, and try and understand where does the reliability, where do we reach the asymptote for reliability, so that we can make recommendations about, given what you're trying to do, how many raters do you need? So there's a lot of challenges, but also a lot of really interesting opportunities to just methodologically to learn how to use these technologies. So we're going to write this paper. I guess one other thing I would say about it, just throwing out exciting things that I find exciting about it, aside from reliability, is the potential for what we refer to as sort of hierarchical or tiered tasking. So one thing we've noticed is particularly has a lot of potential is that you don't need to think about just one target at one task and one group of raters who are going to give you some information about that. You can resubmit so that at each tier, the task you're asking the group of raters is simple, but they're actually simplifying the task for the next tier. So you can take a complex, we call it mining stage, where one group mines the image and we get reliability that what they mined is what they think they mined, and then we can resubmit each of those and ask more specifics, like if we're pretty sure, if we're highly confident that there is a price, then we can resubmit just the price and have another group of people put in the price, so we can maximize reliability so that by the end, you can be really confident. And so it's like, wow, just with almost like a structural process, we can almost eliminate the need to ask about things like, do you agree with you? The whole approach.
So before I thank you, Tom, I see at the corner of the room, I neglected to acknowledge our other sponsor for today's lecture, which is GMI, the Global M Health Initiative at Hopkins. So thank you for that co-sponsorship, because you're on the board of
Steering committee
for the initiative. So that's great. So this was a lot of food for thought, talking about a lot of methodologies, lots of stuff is going on, and lots of really cutting edge work, both using just taking all the pictures and coding pictures, using crowdsourcing to get a lot of data coded, and then the sort of the real-time measurements. So very exciting work. I guess you're never going to be able to retire with all this data and being able to analyze it, but we really look forward to seeing continue to see what comes out of that. So thank you very much for your presentation.
Thank you.
And thank you.